Alright, so the table below gives the population of bats in some caves from 1983 to 2003. They're asking us to find an exponential regression equation that represents the population of the species of bats since 1963. Now, since it says since 1963, that's important because that means we need to make a new second row where we subtract the 1963 from all the years. So right-click on row 14 and say Insert, and we'll put years since 1963. So in the first box, we'll say equals. We will click the year, subtract 1963. And we'll end up with 20 years since 1963. Take the black cross and go all the way across with the black cross. That'll give us the year since 1963 for all of them. Now, we use the second and third row. And with that second and third row, we will create a new scatter chart. So select those two rows and say Insert, Scatter, and there we are. Now to create the trend line, we right-click on one of the dots and then select Exponential. So we right-click here, Add Trend Line. We're going to specify that it should be exponential by clicking here, and then display the equation in the r-squared just in case. So our trend line is 252,860 times e raised to the negative 0.029x. I'll type that here. Now bear in mind that when you do it in Excel, we can't just write the e next to the number. We have to say times and exp parentheses and then enter what comes after the e. Negative 0.029 multiplied by x. Also bear in mind that just like last time, our x is the years since 1963 and our y is the population. So I'll place an x here, a y here. Now they're asking us for the growth and decay rate and the y-intercept of our model. Now this is going to be different from our linear. Now for this problem, our y-intercept is the number that is outside of the e. So we'll say our y-intercept is the 252,860. That was our initial population. So we can say our initial population, according to this trend line, would be 252,860. Now, we have to do a little bit of math to get the growth or decay rate. To get the growth or decay rate, we take exp of the number that is next to x, and then after that subtract 1. So, next to here, we'll say equals exp of the number that is next to x, that's negative 0.029, and then after that subtract 1. Okay, make sure that 1 doesn't go inside the parentheses, make sure it's definitely outside. So we get a negative number as our answer. That means that is our decay rate. Now, if you like, you can convert this to percent by clicking on the percent sign in the number section. Now, you don't have to do this, but I just wanted to show you that it's possible. Click back on this number, click percent, and then we'll add some decimal places by clicking the increase decimal button. So this tells us that the decay rate of the population is negative 2.858%. What this means is that the population is decreasing by 2.858% every year. And I should specify every year since 1963, according to our model. All right, so that's the meaning of the growth and decay rate and the y-intercept. If it's negative, it's a decay rate. If it's positive, it's a growth rate. Now for part C, we are asked to use that exponential model we just found to predict the population of bats in the year 2001. So here's what we need to do. We need to make a new prediction row under the y values and enter our exponential regression equation. That equation was equals 252860 times exp of negative 0.029 multiplied by x. So let's make a new row in row 16 called the predicted population and enter our trend line. Now for our x, make sure that we don't click the year, but rather the years since 1963. Again, we don't want to make the mistake of clicking on the wrong number at this stage. That gives us our predicted population, and we can see it's very close to the actual population. We're getting about 141,000. Now take the black cross and move it all the way across to complete our predictions. However, the question said that we want the year 2001. Now to add a new year, we insert a new column. So let's insert a column right here. We'll add 2001 to the years. And so now let's take the 40 and black cross it an additional time to create our x value, and also black cross the predicted y to create a new prediction that goes with it. So the prediction that comes out, the 84,001.6, is our predicted population if x was 38, meaning the year 2001. So we can say if the year is 2001, our prediction is 84,001.6 for the population. Now to do this, we have to black cross the x row and the predicted y row. However, we leave the actual y alone because we didn't actually gather that data. All we're doing is making a prediction. So we took the 40, black crossed it over underneath the 2001, and then we black crossed the predicted population. So now part D says to use your exponential model to predict the year in which the population will become 50,000. So we are given a new population, and when they give you y, we need to use goal seek. So we are going to goal seek our predicted y to 50,000 by changing the x. All right, so what we're going to have to do is black cross the predicted population over one more time, and we're going to goal seek this new prediction to 50,000. So we click here, go to Data, What If, Goal Seek. The to value is going to be 50,000. By changing cell, now be careful here again, we don't want to actually try to goal seek the year, we want to goal seek the x. So we're going to make sure we click above the prediction in the X row. Make sure you don't miss this one. You don't want to click too high and end up in the actual year, and you don't want to click too low and end up in the Y section. Press OK. The correct X will pop in to the X row. Now, when we goal seek to 50,000, we get 55.89 years since 1963. Now, I want to specify once again, make sure that you put 50,000 in the middle box and put the cell above our predicted Y in the X row, not the year and not the Y value. We have to be really careful we specify this space in particular. So we find that to reach a population of 50,000, we need an X of 55.89. Now, to get the year, we add 1963 back to the X. So we'll come up here. We'll say equals 1963 and add the X value that we found and press enter, and we get that our final answer is 2018. So that means in the year 2018, our population will reach 50,000.